Paula.
Yes, guys. Good evening.
Good evening, sir.
How effective is Zoom? How effective is learning using Zoom?
Good evening, sir.
Huh? I'm asking that how effective is using Zoom?
That is just okay. The only challenge is that the videos are not saved, so you can't go back and recall on what you are learning, but it's just okay.
Okay, the videos are there on YouTube. So you just search Chilungu Kandulo and you'll find all the videos that you're looking for. Do you have YouTube? Maybe you don't have
Yes, sir.
bundles. Maybe you don't have bundles for YouTube.
That's the issue for bundles. YouTube consume a lot of bundles, but we'll try to search for it, to start going for it.
Okay.
Oh, what's the name of the YouTube channel, sir?
Chilungu Kandulo.
Okay, thank you, sir.
Okay.
Sir,
Clopas.
I have a question.
Well,
Why can't the school partner with any network provider so that you start giving us to free on bees for better of learning?
okay, I'll ask Mr. Roge.
Yes, sir.
I'll ask Mr. Roge who will ask in those meetings. I don't go to those big meetings. My job is just
Okay.
to teach you. So I'm gonna start promise nishindewe pafyo. Okay, we're just waiting for some more people to join, then we'll get started. You're so mute on the Start Master. It's like you're only waiting for Zoom. I explained to you that Start Master is what the auditors use to check if you guys are learning and participating. So let's show them that we're doing something. Are we together?
Okay, sir.
Okay. I think we can get started.
Yes, sir, we can get started.
Our topic today is atomic structure, which goes along with the atomic theory. Though, as unfair as it is to the greats, the chemistry greats who've made your lives difficult, I won't really go so much into their theories and what they said. I'll be very selective because at this point now we're looking at the atom. So what is the atom? You remember the atom was the smallest particle of the element that could enter a chemical reaction. So the first person to come up with a model for the atom was an English teacher called John Dalton. At the beginning of the 18th century, in fact, at the beginning of the 19th century, which is in 1803, in that period that when he was very busy, from 1803 to 1810, he came up with certain theories about the atom. So the first statement was to say, elements are composed of minute, indivisible particles called atoms. Then atoms of the same element are alike in mass and size. This was contested, but what he wanted to emphasize was that atoms of the same element had something identical about them. So people came up and said something different to this. Then the third one was that atoms of different elements have different masses and sizes. This was also contested because I'm sure by now you know of isotopes. By then, there wasn't that mention of the word isotopes, because that isotopes are also atoms of the same element, but they have different masses. Then number 4, chemical compounds are formed by the union of 2 atoms of different elements. This is very true and still holds water. So the first statement and the fourth, they still hold water. Then atoms combine to form compounds in simple numerical ratios, which this is also very acceptable, never as fractions. So 1 to 2, 2 to 3. Though this one was also contested because we also have complex compounds, especially with the discovery of organic chemistry. You will find a compound which has C100, H200. So those things. So you understand that this theory was a beginning. There are some people that came after this man that contested. So those of you interested, you can go and read about the atomic theory. Although I won't ask, because I haven't taught it, I won't ask you so much about it to say, what did this person say? So then the last one was atoms of 2 elements may combine in different ratios to form more than one compound. This is also very true, because if you look at the example he gave, it was hydrogen and oxygen. Hydrogen and oxygen can combine to give you water. They can equally combine to give you hydrogen peroxide. So now about the atom, there is also need to understand the concept of charge, because in the atom, there are things there that have a charge. So there was so much. I'm sure those of you who did your grade 12, you've done that experiment of a pen, where you rub a pen in your head and then you try to pick some pieces of paper. What was there was that rubbing created some static electricity. So that rubbing created a charge around your pen. So every time, guys, there should be an understanding of charge. So one of the stuff that you should know, like for the electric charge, is that there are two types of charge, positive and negative. Number two, unlike charges attract. So positive attracts negative and negative attracts positive. And like charges repel. Negative repels negative and positive repels positive. Just like us, like effort to temo bana mayo. We are different from them, but effort to temo. Mo menangwesa ashane shane. Ashane urwimbo. Bagai bakala mulo le shafetala alafu mya dansi. Mba ile dish will just come. No shaking for panono. You find the men. Ba middle le chef. Mama no masipadi mirandu hapo. So unlike charges attract. So now the number 3 there is that charging is by induction or contact. These don't do so much into them. These are in physics. Well, we'll look at the charge. So, but all we were saying is by contact, like there was that contact. There was also by induction where you have a neutral substance there, So you have your neutral substance there, then you bring something with a charge, and the electrons will move out there, and then you can earth that place. So you are inducing the charge. Then there is a force also. There's a force that can be calculated for charges. If you have two charges, you can find their force using that formula. F equals K Q1 Q2 over R squared. This one is called Coulomb's law of electrostatics. It's also so much in physics, don't bother. If I have to explain it in chemistry again, then I have to explain it the time it may become useful. But it's very useful in physics. The K is a constant. The Q1 and the Q2 are charges, separate charges at a distance. So if you have two charges at a distance, then you want to find the force between them, you use that. So we use modulus. It doesn't really, this law doesn't really say if it's attraction or repulsion. It only calculates the magnitude of the force. The charges there, whether it's negative or positive, those are the ones that will guide you to say, since this one is negative, this one is positive. This one, there are different charges, then there's attraction. So Q1, Q2 are charges. These charges are found in coulombs. The unit for charge is coulomb. Then the R is the distance between them. The distance between them. So how far are they in meters? That's what you find in space. So now the next person, after looking at charge, is that the same concept of charged atoms. Charged atoms are called ions. So by definition, ions are electrically charged atoms or groups of atoms. These were discovered by Michael Faraday. Michael Faraday discovered that certain substances, when dissolved in water, could conduct electricity. And those substances were the ones that were termed as ions. Then for us now, after more discoveries, it was actually discovered that those are atoms or groups of atoms, but with a charge. So the positive ion is called the cation. The negative ion is called the anion. So you must know that. So most importantly, are the subatomic parts of the atom or subatomic particles of the atom. So as you know, guys, that the atom is very small. The ranges are those 1 to 5 angstrom. 1 to 5 angstrom. An angstrom is 10 to the power negative 10 meters. Guys, extremely small. But then we're saying that even as small as these atoms are, they have subatomic particles, which are called electrons, protons, or neutrons. These ones are specific. Then we describe the electron. Electron is found around the nucleus in the subshells. So now, if the mass of the electron is very small, so it's 9.11 times 10 to the power negative 28 grams. It's very small compared to the hydrogen atom, and the hydrogen atom is almost always just the proton, because hydrogen just contains one proton, one electron. So now, if the electron is lost, that's why sometimes when you find a book or reading a book, they tell you a proton is released, or they're defining acids. They say acids are proton donors. And yet, in the equations you see, what they put is H+. H+ is also a proton because hydrogen contains only a proton and an electron. So if the electron is lost, then all that remains is a proton. The numerical value, the actual value of charge, is negative 1.602 times 10 to the power negative 19 coulombs. Though this one is not used because it's a bit cumbersome for our chemistry to use this very small. So this one, its usage is usually just in thermodynamics and electrochemistry, but you don't really use it. We use what is called the relative charge. The relative charge that is assigned to the electron is -1. So if someone asks you what is the total charge, what is the net charge, you look at how much the protons and the electrons are more than each other. So the relative charge is -1. That is one. It is there's also information on the diameter of the electron. Don't bother so much. Just know that information is just there for us to appreciate that diameters of electrons are extremely small. So now, if we continue, we'll go to the proton. So guys, the proton is positively charged. The proton is positively charged with mass 1.673 times 10 to the power negative 24. Actual charge plus 1.602 times 10 to the power negative 19 coulombs. So you actually see that the charge of the proton and that of the electron are the same. The proton is found in the nucleus. It substantially contributes to the mass because it's very big, almost 2,000 times the mass of the electron. I think the value is there, 18 something there, 1837. So now, these two, if you have the proton and an electron, their charges cancel out. So in a neutral atom, the number of electrons is equal to the number of protons. What is a neutral atom? Where the net charge is 0. The overall charge is 0. So if you have protons and neutrons, they cancel each other out. So that is the reason in there. If you have protons and electrons, they cancel each other out because protons are positive, electrons are negative. Then these values we've said they are numerically the same. The only thing that is different is the charge. Then when we move, so I've already said about that. Then when we move in the same nucleus, you find the neutron. So the neutron is neutral. It is neutral. It is neither positive nor negative. It doesn't have any charge. Then its mass is approximately the mass of the proton. So those are the masses. So you see that this one also contributes to the mass. So when you're getting the mass, you consider the protons and the neutrons. When you want to get the charge, you consider electrons and protons. So those are the things. Electrons are very important, guys, because electrons are the ones that participate in chemical bonding. You remember chemical bonding, which is a chemical reaction, is simply the transfer or sharing of electrons. So now, that's what we mean when we say electrons are very important because they are the basis for the chemistry. So the table there summarizes everything that we've mentioned, that the relative charge is -1, plus 1 and 0. So those are the things. The neutron and the proton are in the nucleus. The electrons are outside the nucleus in the shells or the orbitals. Orbitals are the specific locations where electrons are found. We'll talk about those in the next lesson. So they are in energy levels. So today's biggest point is the mass number of elements. So it's the mass number and the atomic number of elements. So the atomic numbers of elements, one, the atomic number Z of an element is the number of protons in the nucleus of an atom of that element. So what that means, so the number of protons is very important because it's called the same thing, it's called the atomic number. So meaning in a neutral atom, the atomic number is also the number of electrons, except in ions, it's different because ions means it has gained or lost some electrons. So now, so meaning you have either a neutral atom or an ion. You must understand that perspective. So the atomic number is important because it determines the identity of the atom. For example, if you find that the atomic number of an atom is 1, then all those atoms are of hydrogen. All of them, you state them as the atoms of hydrogen. If the atomic number of the atoms is 6 and they are different, regardless of their masses, then they are all atoms of carbon. You find it's 92, the atomic number, then it's uranium. To a plant, yama bomb, uranium. So those are the things. So when you mention the atomic number, then you just simply have to talk about isotopes. Isotopes are atoms of the same element with the same atomic number. The atomic number is also just simply called the proton number, with the same atomic number, but having different mass numbers or different masses if you want. The mass number, since the mass of the atom is the nucleus, it's also called the nucleon number. So those are the things. So you must understand that aspect, that you have what are called isotopes. So isotopes can be written in this way. This is called isotopic notation. So this one, these are isotopes of hydrogen. All of them, the atomic number is 1, but the masses are different. These are small, guys. These are small. In nature, they are very small. These two isotopes are very small. But this one is in abundance. That's why we stick to it to say the mass for hydrogen is still 1. When you find the average of this, it still becomes 1. So now, these ones, they have special names. Although we just say hydrogen, I want to explain that NASA setting up another name. So this one is protium, deuterium, and tritium. Those are their special names. Then to write an atom like the notation like this, you write where you indicate the mass and the atomic number and the symbol of the element. It's called isotopic notation. So I asked your friends one time to say, deuterium reacts with oxygen. What's the name of the product formed? They looked for periodic tables. Na fire bad. Element more periodic table. That's what they were saying. And yet what I meant was that it's hydrogen. So I wanted the answer water. Badi kana man. But that's what you should know. These isotopes, when they enter reactions, they enter reaction as the element. Some elements are special names. These are the only ones with special names. So there's a question there, what are the special names of this? No. The only ones with special names are the ones that you've stated there. The rest, just call them as carbon 14, carbon 12, that's enough. So this is how we write isotopic notation. The A is mass number, which is the mass, the number, the total sum of the protons and the neutrons. So protons plus neutrons, that's mass number. Then protons alone, that's atomic number. The mass number, as I've said, is also called the nucleon number. So those are the things. So most of the things in nature exist as isotopes. So like oxygen has 16, then there's oxygen 16. So in fact, also oxygen has 7. Then there's oxygen 16, oxygen 17, and oxygen 18, which are the ones that are stable. Then also carbon has 7. Then there's carbon 12 and carbon 13. They are stable. Arsenic has 15. This arsenic is the one I told you it's a good poison if you want to kill like your husband. And then you start putting on the drink. And then no. Akesa afwana ngwati mu December nango October nishadi sign kale will. It's used a lot, arsenic, those of you who research the most. So the relationship between mass number and the atomic number is that when you subtract out the atomic number, you remain with the number of neutrons. So that is almost the case. I've talked summatively because things are straightforward. It's grade 10 work, I know, but I still want to give you time to ask questions. Are there any questions? Guys, where do I have to elaborate more? Class. So these are the scenarios. So like fluorine, you search fluorine is fluorine 19. So when you say fluorine 19, it means fluorine with mass number 19. Yes, Robert. Yes, Robert, you can say.
Sir, I just want you to qualify more of the relative atomic number of, actually the relative, yes, atomic number of the neutron.
Na ikaba wedio relative where kosa. Lenga shavyonze filubana but relative. We'll come and look at relative masses of atoms. Remember, relative means compared to. So we'll look, that's the next topic we'll come and look at, the relative masses of atoms. But the mass of the neutron, as we stated, was just slightly bigger than the mass of the what? The mass of the proton. So their relative mass, Mr. Robert, is 1 atomic mass unit. Both of them, the proton and the neutron, we take them as 1, 1. So meaning if you have 3 protons and 4 neutrons, 3 plus 4 is 7, then we'll say 7 atomic mass units. So we'll just say 7, we'll just add that by relative. But then the actual mass is 1.675 times 10 to the power negative 24 grams. If you take this to kg, it becomes negative 27. Then this one becomes negative 31. There's another person who has raised their hand. Francis. MJ Francis. MJ Francis, tell me what the question that. Raise your hand. Yes, you can say. Francis.
I wanted to ask, sir.
Yes.
What keeps the protons in the nucleus? Because the protons and neutrons cannot attract each other. So what forces pulls them together? Because if you look, you said electrons are negative charge and protons are positively charged. But why don't they pull each other in opposite direction to move away from the nucleus?
No, the only ones in the nucleus are the neutrons and the protons. If I said that, then it slipped out just. The neutrons do not have a charge, so they can stay with each other there because the nucleus is a core there, stored with energy. It's energy that keeps them there. But the neutrons and the protons, There's nothing there because the neutrons do not have a charge. Wow, protons have a positive charge. Then around now, that's why you find the negative charges in the shells of electrons, which are also held together by that same attraction. So that's why the atom is intact like that. So in the nucleus, there's only a positive charge and a neutral charge. That's why they stay together like that. Gabriel, you have a question? Gabriel. Okay. Any other question? So key, guys, is let's understand the notation. Let's understand that isotopes are atoms of the same element. Like I have told your friends, I mentioned deuterium reacts with the oxygen. What is expected? I expected them to say water or hydrogen peroxide, but then they didn't know. For them, they thought isotopes is different. Do not isolate that. Isotopes are atoms of the same element. So when they enter the reaction, they will react the way the element is expected to react. Make sure you understand that concept. Someone was asking me, where do isotopes come from? They are found in nature. They are found in nature. Though some can be artificially made using radioactive labs. So those are the things. So someone, your question now, where do isotopes come from? So don't, the application is what we need. Then just the other thing, the sum of the protons and the neutrons is the mass number. Because I've turned the atomic number. The sum of the protons and the neutrons is the mass number. The mass number is also called the nucleon number, meaning it's the mass of the nucleus. So please do not forget that. Then an atom can either be neutral or charged. So when it is charged, then you call it an ion. So those are the things you must grasp. Try to grasp those things. That's the notation. Those are the notations. Because most of the times we'll give you equations and we'll give you isotopes. Then we'll tell you what atoms are these. So for you to know what atoms those are, what elements those atoms are of, you look at the proton number. Always look at the proton number. So meaning, if you have, where is that? So meaning if you have O16, O17, O18, if we wrote these ones as X, Y, Z, then we tell you identify them. All of them should be oxygen. All of them should be oxygen. So those are the things. Some more people have raised their hands. Matthews, Luxion Mutende.
So I have a question.
Yes.
How do you calculate the number of electrons in an atom?
The number of electrons in an atom, when the atom is neutral, the number of electrons in an atom is the same as the number of protons. So just an atom, just like that, the number of protons is equal to the number of protons. Always, number of electrons equal to the number of protons. Number of electrons equal to the number of protons. Except when you have an ion, because an ion means the atom has either gained or lost electrons. So still, if you have been given the atomic number, you can know how many, by looking at the charge, you can know how many have been gained or how many have been lost. Say you are looking at oxygen. Oxygen, then you find now that O2 minus. Then you find oxygen is 8. The atomic number is 8 for oxygen. Then it has 2 minus, meaning it has gained 2 electrons. So meaning the number of electrons now will be 8 plus the 2 gained. because of the negative charge, then that will be 10. So the same case for sodium. If you have Na plus, you will find Na plus, then sodium minority, its atomic number is 11. But then the K plus tells you that it has actually lost an electron. So meaning when it was neutral, the electrons were 11, then it has lost 1. So it means to also remain with 10. That's how you find the number of electrons. So there's a bit of reasoning there. This question that you have asked my friend Luxion is very good because those are the things that are found in multiple choice questions. So if someone doesn't know that reasoning, then they will struggle. Yeah. Any other, we can sneak in one question, then explain, conclude, and stop. Any other? Okay. Francis, you have another question? Namunira in hand hapa first. Francis, do you have another question or it's the same hand you raised at first?
No, I don't have a question, sir.
Okay, it's okay. So guys, go and revise these. These are very simple concepts. If you feel like the explanation is not sticking, switch to your high school. I'm sure you haven't given out those. Switch to your high school and go and analyze those things. So please, these are simple concepts. The keyword we've defined here today are atomic number, mass number, and isotopes. Make sure you understand all of these. Even when I said this is cumbersome, meaning on a day-to-day, but some of these, like the charge of the protons, charge of the electrons, those are key things you must keep. That's the way it is. The only thing I disputed a bit is to ask you unfairly the diameter of the electrons. It will be very unfair, but I've already put all those things. So these scientists like Faraday, and the first one who is John Dalton, there were other, these are early scientists. There were other ones now who came and put in modern chemistry. So please try by all means to analyze. If you want, you are interested in the chemistry, you can even see who did things after. So guys, we have charge, meaning if there's a charge, especially for the ion, it has either gained or lost electrons. That's how it becomes ion. Then the one that gains becomes negative, the one that loses becomes positive. Like the Bible, blessed is the hand that giveth. Then we have subatomic particles, there are those. Then lastly is to say, especially when I was talking about the neutron, this point is key. To say there are also other stuff which are subatomic particles, mesons, positrons, neutrinos, and antiprotons. These ones were just recently discovered, but it hasn't really been known if they actually found in the atom as intact. That's why we don't use them. But those people who do radioactivity, they actually analyze these things and look at them because they're very helpful in medical imaging and all. So those are the things. Enjoy your day, guys. See you on Wednesday. So go and read on this. On Wednesday, our next topic is the same atomic structure and atomic theory. Plus, we'll look at the orbital electronic configuration. Okay? So, some of you